Hello friends, I'm the blog. I am still your humble tutor, and today we'll be looking at Surds. Now, but if today is your first time on our channel, please don't forget to subscribe. And if you have any questions, don't forget to leave them on the comment section below. Alright, so let's look at what we have in stock for you. Now, we'll be starting with the definition of Surds. After which we'll be looking at the laws of Surds, or basically the laws that guides operations and calculations in Surds. After which we'll be looking at the addition and subtraction of Surds, then the multiplication and division of Surds. Now, basically, division is rationalization of Surds, okay? But when we start, you'll understand what I mean by division and rationalization of Surds. Now, after which, below this video, you'll find the link to more exercises under Surds. So if after this video you feel that you need more exercises under Surds to help edify and prepare you, now this is the link for you. We also have the link to past questions, your WAEC, your WAEC Communico past question, your JAMB past question, your UTME past questions. Now these are questions under that were solved in details. So if you're a student and you fall under any of these categories, now you need these past questions. But also on you link to 500 boosters. Now I don't need to say more about 500 boosters. Now because it is a summarized mathematics. It contains questions just on now but under every topic in mathematics. So if you need any of these things, why not put the link below this video? Alright, what is a surd? A surd can be termed to be an irrational root. Now, what do I mean by an irrational root? Now, we all know that we have our second root, which you know as our square root. We have our third root, we have fourth root. Okay? Now, if I begin to look for the square root of 27, or I begin to look for the third root of a number like 81, or if I begin to look for the fourth root of a number like 8. Now, we know that 27 has no perfect square root. Now, we know that 81 has no perfect third root. And we know that 8 has no perfect fourth root. So, these kind of numbers are the numbers that we refer to as surds. Now, but for the sake of this video, we'll be basing on our second root, or basically our square root. Okay? So it means that the surd we'll be discussing will be the surds in this form, where we'll have our root to be the second root. So this is what our surd looks like. Now, what is a surd made up of? Now, the number that we are looking for its root is known as the base of the surd. Okay? Now, a surd also possesses what we know as coefficient. Now, for example, here, because our coefficient is 1, it is not being indicated. Okay? Now, we can have something like b root a. Now, where this is our base, this is our coefficient. Alright, so let's look at the laws that guides surd. Our first law of surd. Our first law tells us that if we have a, now this a is acting as a coefficient, a root m times b root n, that the solution is equal to, now the product of my coefficient, which is a times b, then the root of m times n. To have this to be ab root m n. Okay, so it means that if I have f root 3 times 3 root 4, now from our first law it tells us that the solution to this is 5 times 3, then root 3 times 4, which is equal to 15 root 12. So basically, this is what our first law tells us. Our second law tells us that if I have a root m all over b root n, that the solution is equal to a all over b times root m all over n. Okay? So if I have a root 12, sorry, let's say 2 root 12 all over 3 root 3. Now from our second law, it tells us that the solution to this is equal to 2 over 3 times root 12 all over 3. Now we know that 12 divided by 3 will give us 4. So we'll have 2 over 3 times root 4. Now this is a perfect square root. So we'll have 2 over 3 times 2, which is equal to 4 over 3, which is equal to 1 over 3. Okay? So basically this is what our second law, our second rule in Surds tells us. Our third rule, what does our third rule say? The third rule says that root m times root m is equal to, now from our first rule, it should be m times m, right? I know that m times m is m squared, so this is root m squared. Now I know that this we cancel our square root to have m. Okay, so this means that if we are looking for the product of any two surds that are of the same base, that the solution is equal to the base of that surd. Now what if we have coefficients here? For example, if I have a root m times b root m, now it is still basically the same thing. From our first law, the solution should be a times b, then times root m times m. Okay, so this becomes a times b times root. Now m times m is m squared. All right, so this gives us ab. Okay, now this is root m squared. I know that our square will cancel our root to have ab times m, which is equal to ab m. Okay, abm. So let's see an example. If we have 3 root 2 times 5 root 2, our solution is 3 times 5 times root 2 times 2, right? Now our base. So we'll have 3 times 5 is 15. We have 15 times root. Now 2 times 2 is 4. Now we have, know that the square root of 4 is 2. So this is 15 times 2, which is equal to 30. So basically this is what our third rule is all about. Alright, now our fourth rule. Now let's look at this rule carefully. Now it tells us that a root m. Now remember we said that this part is our coefficient part. Now but this rule tells us that this very particular expression can be rewritten to be root a squared times m. Alright? This is root a squared times m. Alright? So this is basically what our fourth rule says. So it means that if I have 2 root 3, now that it is the same thing as root. Now this is 2, right? So I'll have 2 squared times 3. So here I'll have root 4 times 3, which is equal to root 12. Okay? So if we still have 3 root 5, if we still have 3 root 5, now from our follow it tells us that this is the same thing as 3 squared times 5. I know that 3 squared is equal to 9, so we have 9 times 5, which is equal to the root of 45. So basically, this is what our fourth law tells us.